Brilliant. Okay, so I think this is recording. Good. So yeah, first, thanks, Simone, for a wonderful talk. I thought it was absolutely fascinating, the sort of breadth of research you've been working on. As I kind of mentioned earlier, we've been doing sort of some informal discussions after the talks to sort of find out a little bit more about your kind of journey in science and how you got into what you're doing now and some of your views on the fields as more generally. So the first question I've got is basically, what got you started in science and eventually led you to looking at kind of micro robotics and kind of biomedical engineering? What was your path to where you are right now?
A great question. And also thank you, first of all, for this wonderful opportunity to give this talk today. I think all right, so what led me to microrobots? I've been always really interested by the natural sciences. I had a math and physics was basically what I focused in high school and trying as the means to understand the world. And then I remember when it was really my first look through an electron microscope and feeling kind of this vast amount of space at the nanoscale was just so intriguing to me. And then kind of thinking of, but how could I could spend days really, I mean, not literally, but actually literally spending days on like scanning surfaces, but then really just need to interact at the scale. Or how could you, not only observe, but really engineer, and then learning about these specific nanoscale phenomena, how physics in a way is different because of other dominating forces, was something that I found just super challenging to think about, to kind of rethink engineering, and that got me into that. Yeah.
No, it's cool. Yeah, I think the first time I saw an electron micrograph, it's just the fact that often things look so perfect, almost like they said, there's so much symmetry that kind of self-assembly relies on that you just wouldn't imagine could occur at such a small scale. It's absolutely fascinating. So it's kind of more your view on things, but what do you feel currently then are the biggest challenges or hurdles within your field, and how do you think they might be overcome, sort of looking forward?
Yeah, I think, when we think of micro nano robots, the first question that usually arises is, how do they get out of the body? How can we make sure we have control over them? And so I think just the materials we choose, the biocompatibility, the degradation, the interaction with the immune system, and having really, the profound knowledge on all these pathways and control over that is crucial and essential. And then basically I think what our great engineering problems are, then you have these constraints on your material, and then thinking about, so how can I localize, how can I detect, what are ways to basically follow that in vivo in deep tissue and have this control about which energy transfer ways of energy transfer make sense, what other principles of motion, of actuations can be implemented. And there we don't have joints, we don't work on this macromechanical on such macromechanical aspects. We think about what kind of chemical reactions can I produce, or changes that then change something again, that mechanical properties that give a different acoustic signal, or magnetic properties that change that give a different magnetic signal that I can well resolve outside the body.
Do you think so? So obviously there are these engineering challenges, some of those you highlighted, like making these things is really difficult and controlling them. But then I guess with any kind of medical field, you've also got the regulatory side of things in terms of that potentially kind of limiting the sorts of things you can do, or making it very difficult to kind of sort of take things forward in certain directions. And do you think they're equally difficult at the moment, or that the engineering problems can be overcome and the regulatory ones are always going to be the kind of the limiting factor, or is there there are other sort of things going on that you think are going to be challenging?
I don't see it separated. I see it really as the regulatory aspects are defining the design space we have. Mm-hmm. And that's, starting off with the materials we use. So trying to build off already on material that is approved, thinking, of course, of the way of the energy transfer that obviously that can be taken by the body. What are the limitations of magnetic energy and so on? So, and it is all well understood, so we know in which range we work. So I really don't see it as it makes basically the engineering problem harder, but I don't see it as a step we think about afterwards, because you need to think about it from the beginning.
No, so that's an interesting look at it. And so if you're looking forward, I don't know, 10, 20 years, how do you see kind of micro robotics then? Is it going to be like in the films, like where you have these little robots with hands and they're going around, or is it going to be completely different to that in some way? Do you have any kind of feeling for where you see the field long term going, and what that's going to mean for me, like day to day?
Yeah, I mean, I think definitely not little hands and joints, like this idea of machines we have. I think it will be different in a way that we are more analogous maybe to living organisms, to small living organisms, but a lot is happening also in the biomaterials, bio-inspired materials. What is happening, because nature has provided already wonderful solutions that work at that scale. I think a combination of these biohybrid agents, what we are also working on by combining basically intelligence from living organisms, combining with external control by adding other nanomaterials. So really also a fusion of disciplines coming here together. I think, probably, and a lot of, I think aspect of softness, soft micro systems that kind of match well with what else we're encountering in the body, and thinking about really these properties and interactions, I think will be key. And I think that is kind of towards how that will look like, less than little metallic machines.
Yeah, so I think there's going to have to be some new films made, like actually what these micro robots actually look like in some way, which would be fun to do. Okay, so the last question I have is a more general one about. So one of the things I like to ask is if you have any advice for students that are maybe starting out in thinking. I don't know, maybe they saw your talk and they thought, micro robotics is what I want to do going forward. Do you have any advice for how they can best get into that area, or some of the things that have happened where you wish you'd known that before you started doing something or approached a problem in a particular way?
That's a great question. I don't know. There are some old papers that are really, like from Purcell Life at Low Reynolds numbers, for example, that's just beautiful and taking you kind of on a journey of how microorganisms move. I think this is as I foresee, kind of really this combination of working also with living organisms as a micro robot, I think, and it really helping understand the physics. I think this is a great resource. There's of course lots of other wonderful literature, and I don't want to single out more, but I think it's basically reading, approaching people in the community who, there are cool conferences. There's also a nature conference on micro robots. Like, I think the community is growing, like kind of engaging directly there, asking curious questions, not be afraid of asking questions, and and as simple as it sounds, but reading.
Yeah, I think asking the questions is a great one as well. Like, sometimes I remember when I was a lot younger at conferences, you'd be really nervous just putting your hand up, but it's so important, I think, because often the question you have is the same question that a lot of other people have, but everyone's a bit nervous about doing that. So it's great advice, I think. Brilliant. Well, that's all my questions. So I just want to again thank you so much for your talk, and I can't wait to see what new creations you come up with in the next few years for curing cancer and all these other diseases that you're looking at. Thank you so much.
Thanks so much, Tom. Such a pleasure. Awesome.